Skills intelligence in HR tech. AI ontologies with verifiable credentials. Skills intelligence is the idea of using data and AI to understand and match people's skills with job needs. Today's HR and talent systems face big challenges: fragmented skills taxonomies and unreliable resumes. Traditional skill lists are often outdated noise. For example, one study found a large company spent months and millions of euros building a skills list, only to see it obsolete before it was printed. That shows standard taxonomies can quickly fall behind. Meanwhile, job applicants have become very good at presenting themselves on paper, a trend SHRM calls skill phishing. A recent SHRM survey found 63% of people worked with someone who looked great on paper but lacked the skills to perform once hired. In other words, resumes and traditional signals, degrees, titles, are noisy and sometimes misleading. This hurts workforce planning because leaders can't trust that skills data is accurate or up to date. To fix these gaps, we propose an AI-driven ontology builder. In simple terms, this is an AI system that constantly builds and updates a structured map of roles and skills. Think of it like a smart network knowledge graph that links each job role to the exact skills needed, plus the proficiency level or credentials required. Unlike a static spreadsheet, this AI system updates itself from real-world data, like job market signals, so it stays current. For example, one HR tech platform models the labor market as a knowledge graph, where skills, roles, and worker transitions are connected with weighted links. It updates daily from millions of job postings and career events. This lets you see not just does a person have X skill, but how far is this person from the target profile, and what training closes the gap, and how quickly. The Ontology Builder also integrates verifiable credentials and assessment signals. Verifiable credentials are digital certificates, like a university degree or professional badge, that are cryptographically secured and can be checked instantly. In practice, this could mean linking directly to blockchain-based or issue-assigned skill badges. For example, modern skill credentials might include the skill name, level, issuing organization, and date, all stored in a tamper-proof way. Because each credential has cryptographic proof, it cannot be forged or modified. HR knows that a claim is real. The system would also pull in assessment results, exam scores, course completions, work samples from learning management systems, LMS, or online tests. This ensures the skill profile for each employee or candidate is backed by evidence, not just self-reporting. In short, the AI ontology maps roles to skills, and it cross-checks every skill claim with a verifiable credential or test result. Building the AI skill ontology. The core of our solution is a dynamic skill ontology knowledge graph. Here's how it works. Data ingestion. The system ingests text from job postings, internal project descriptions, resumes, CVs, and learning content. It can use AI, natural language processing, to extract key skills and tasks mentioned. Over time, it learns which skills tend to appear together and how people move between roles. For example, it might notice that many data analysts learn Python, or that project managers often transition into product roles. Graph construction. The AI constructs a graph where nodes are skills and roles, and edges show the relationships. Edges are weighted by how strongly two skills are connected, or how often transitions happen. Unlike a simple tree, a graph can capture that a single skill like communication has different meanings in different jobs, or that two seemingly unrelated skills may actually be closely linked in practice. Automated updates. The system regularly updates its model from new data, e.g., daily or weekly. Because it's data-driven, it can pick up emerging skills like prompt engineering or carbon accounting right as they become relevant, without waiting for manual taxonomy changes. Role to skills mapping. For each job role in the company, the platform generates a profile of required skills and proficiency levels. These profiles come from both the company's own job descriptions and the broader market data. For instance, a role definition in the AI system might say, Cloud Engineer requires AWS, Python Advanced, Security, DevOps, with link weights showing importance. If an employee's profile, from their history and credentials, matches 70% of the required skills, the system can show exactly which 30% are missing and suggest training pathways or alternative candidates. Verifiable credentials integration. Each skill in a person's profile is tagged with evidence. If Alice has a data science certification, advanced, from XYZ Institute, that's a verifiable credential. The system records the credential details, issuer, date, level, and links it to her skills. Or if Bob got 85% on an internal Java assessment, that score goes into the graph as an assessment signal, validating his Java skill. By requiring these proofs, the platform avoids relying on unverified resume claims. Blockchain or W3C-style verifiable credential technology ensures certificates, like diplomas or online course badges, are cryptographically signed, so employers can trust them. User interface. HR and managers see a dashboard that shows workforce skills at a glance. Which teams have skill gaps for upcoming projects? Which employees could be ready for promotion if they learn X skill? Or an alert that a key role will need a new hire if no internal candidate closes the gap soon. All these insights come straight from the AI-generated ontology and real data. In short, instead of manually maintaining lists of skills, this AI ontology learns from actual work data and credential signals. One expert puts it this way: the system gives you numbers, gaps, upskilling time, not just verdicts. For example, it might compute a nurse matches 68% of a nurse practitioner role, 7 subskills are missing, requiring a 14-month training path. That turns vague skills gap talk into concrete, cost-driven decisions, e.g. retrain versus recruit. Integrating with ATS, LMS, and HCM systems, for full value, the ontology builder must tie into existing HR tools. ATS, Applicant Tracking System. When a job user posts a role, the ATS provides the initial role profile. When candidates apply, the AI can scan resumes and match each candidate's verified skills to the role. Importantly, once a candidate is hired, ATS status changes. The integration can automatically create an employee record. For example, a best practice integration is, when a candidate is marked hired in the ATS, the system auto-creates the employee in the HCM and pushes their data to the LMS and learning systems. This means new hires are immediately entered into the skills platform and enrolled in any mandatory onboarding courses without manual work. HCM, HRIS systems. These systems, like Workday, SAP SuccessFactors, etc., hold the core employee data, role, department, history. The skills platform pulls this info to understand who does what job. In return, it can feed back skill profiles and suggested learning paths into the HCM's talent module for things like succession planning. For example, the HRIS can display each employee's skills ratings as built by the ontology right in the HR profile. When performance reviews happen, the manager can see which verifiable skills an employee gained and where gaps remain. This creates one single source of truth for skills across the enterprise. LMS, Learning Management System. Training and learning systems are crucial for supplying assessment data. Suppose the LMS runs a series of courses or quizzes to teach certain skills. The ontology builder can import completion reports and test scores as signals. For instance, if the LMS logs that Carol completed Excel mastery with 92%, that feeds into her skill graph as evidence of Excel proficiency. The LMS competency connection is well known. An LMS is a digital classroom that tracks learning progress. By integrating it, we automatically push new skill evidence to the ontology. Completed courses or certification badges raise the employee's skill level. This matches the best paired scenario where a competency skills system tracks assessments from the LMS. In practice, an integrated flow works like this. The ATS knows when a person is hired, triggering their profile in the HCM and enrolling them in any required training. ATS, HRIS, LMS flow. The employee then takes online courses. When they finish, the LMS sends their scores to the skills platform. If they also pass a certification exam, that credential, via a partner like Credly or a blockchain badge, is keyed into the system. Managers can then see updated skill profiles in their HR portal without logging into many tools. By linking all these systems, the organization avoids one-off spreadsheets. Every training credit or resume entry flows through the same central skills knowledge base. This unified ecosystem approach is proven. ATS, HRIS, LMS integration speeds onboarding and ensures new hires hit the ground running with digital training automatically assigned, while the LMS integration flags skill gaps and suggests next courses. Each component, ATS, HCM, LMS, plays its part in a seamless skill-to-role feedback loop. mitigating bias and ensuring fairness. Any AI-driven HR tool must proactively address bias. Skill and hiring data often reflect societal biases, e.g., historically fewer women in engineering. If unchecked, an AI ontology could reinforce skewed patterns. So we build bias safeguards into every layer. Data auditing. Before training the AI, we carefully audit historical data for imbalances. For example, if past promotions favored one demographic, the AI could overvalue characteristics shared by that group. We use statistical tests to spot proxy patterns, e.g., a skill that correlates with gender or zip code, and adjust or remove bias signals. Fair algorithms. We choose or adjust machine learning methods to promote fairness. This might mean using fairness-aware ranking algorithms or reweighting input features. The goal is to prevent the system from simply reproducing old hiring patterns. For example, we might enforce that similar candidates on paper receive similar role match scores, regardless of protected attributes. Continuous monitoring. After deployment, we monitor outcomes. If the AI predicts which employees to groom for leadership based on skills, we check the actual demographics and review whether any group is being under- or overrepresented. The process is iterative. As one guide notes, AI bias mitigation is each cycle of measurement, adjustment, and validation until equitable results appear. Automated logs record decisions for auditability. Protocol and governance. We follow standards like the Data and Trust Alliance's guidelines for AI in HR. By requiring vendors to answer detailed questions on bias detection and by measuring their scores, HR teams can choose partners that commit to fair practice. For example, many HR systems now offer compliance modules to flag biased language or outcomes. In short, our workflow embeds checks at each stage. The skills data collection is cleansed, the matching algorithms include fairness constraints, and the team runs scheduled audits. The system surfaces explainable reasons for its decisions, e.g., which skills caused a match, making it easier for humans to spot anomalies. Research suggests this holistic approach can significantly reduce bias while preserving the efficiency gains of AI. Pricing model and value metrics pricing. We recommend a transparent per-user subscription model. For example, if we set the price at $10 per employee per month, around $120 per year, this aligns with market norms for HR SaaS. Many HR platforms charge in the single-digit to low double-digit range per user monthly. For context, one pricing survey shows tools like Bamboo HR at about $10 user per month, Lattice at $11, and others ranging $5 to $20. Our specialized skills engine, which adds predictive AI and integration value, could be slightly higher or bundled with other enterprise features. Volume discounts would apply when deployed company-wide. The ultimate ROI is seen in faster hiring, internal mobility, and cost savings. Key metrics include time to fill, time to hire. This measures how long it takes to fill a position. By having instant visibility into who in the company can fill a role and what training they need, companies can hire or move people faster. For example, research shows that focusing on internal talent pipelines can shave off roughly 10 to 12 days per hire compared to external recruitment. If the average time to fill is cut from 60 days to 48 days, the cost and productivity gains are huge. Our platform's internal talent marketplace can drive these improvements by recommending qualified internal candidates first. Internal mobility rate. This is the percentage of roles filled by existing employees. Higher internal mobility means lower hiring costs and better retention. Currently, many companies only fill 22% of roles internally. A world-class program might push that toward 40% or more. Each additional internal placement saves roughly 4x in cost. SHRM reports external hires cost about $4,683 versus $1,094 internally. Also, internal hires start faster. LinkedIn data shows they reach full productivity in 32 days versus 92 days for external hires. By showing managers the skills of current staff, our system makes it easy to consider internal candidates first. If internal fill rate goes up, time to productivity drops, and attrition declines too, employees given career paths tend to stay longer. Hiring cost and quality. With better skill matching, fewer bad hires will occur. Skill phishing losses, hiring someone misrepresented on paper, can be costly. If our system prevents even one bad senior hire, it can pay for itself. Additionally, Each internally trained employee reduces the need for outside searches, saving agency fees and ramp-up time. Learning and development ROI. Because our platform recommends targeted training for exactly the skills needed, training programs become more effective. We can measure course completion rates and tie them to role advancement. Over time, this shows up as higher promotion rates and lower external hiring. We would track these metrics against benchmarks. For executive reporting, we might cite an internal move program can increase engagement 3.5 times and retention 2.6 times, according to LinkedIn. We'd set targets like increase internal fill by 10 points, cut time to fill by 20%, and quantify the corresponding cost savings. A demo ROI case might show that even if the system costs about $10 per user per month, it cuts hiring costs by 50% on certain roles and yields a 3 to 5 times return through the savings and faster productivity. Enterprise change management. Adopting this new AI-driven skills platform requires careful change management. We suggest a phased rollout using best practices. Assess readiness, gauge the current skill management process. Survey HR leaders and managers. How do they track skills today? What pain points do they have? Use this to build support. This mirrors the Phase 1 assess readiness step recommended in HRIS adoption guides. Executive sponsorship. Secure buy-in from senior leaders by demonstrating business impact, cost savings, agility, talent retention. Leaders should communicate that the goal is not to grade employees, but to empower career growth. Stakeholder engagement. Form a small champion team from HR, IT, and a couple of pilot departments. Involve them in pilot testing. For example, have one department try filling an open role using the skills tool and gather feedback on the matches and suggestions. Training and communication. Develop simple materials, videos, user guides, explaining how managers and employees use the system. Run live training sessions. Emphasize benefits, e.g. employees can see career paths, and hiring managers get better candidate matches. Provide a FAQ that addresses trust concerns, data privacy, fairness. Pilot and iterate. Roll out to a pilot group of users first. Gather data on how often it's used and adjust configuration. Use the AI's explainability to fine-tune the skill mappings. Example, tweak role definitions or remove any obviously unfair patterns. Document and resolve any surprises. Full rollout and support. Once tuned, deploy company-wide. Monitor key adoption KPIs. Example, percentage of job postings using the system's suggestions. Internal application rates. Course completions from recommendations. Offer office hours or support for early inquiries. Sustain and reinforce. Periodically update stakeholders on successes. Example, we filled X roles internally this quarter, up from Y last year. Schedule quarterly reviews of metrics. Refresh training for new employees. Keep IR saying this is a long-term effort, as in Phase 4, sustain and reinforce of the change framework. By following a structured approach, the enterprise will gradually shift from old habits, paper resumes and intuition, to an evidence-based talent practice. Over time, the skills platform becomes an integral part of HR planning and career development, rather than a one-off tool. As experts advise, successful HR system adoption depends not just on the technology itself, but on preparing people for change. Our plan covers communication, training, and continuous improvement so that the solution delivers on its promise. Conclusion: bridging the gaps of fragmented skill lists and dubious resume claims is essential for modern workforce planning. An AI-powered ontology builder, paired with verifiable credentials and live assessment data, offers a comprehensive solution. By mapping real roles to real skills and cross-checking every claim with proof, organizations can make smarter hiring and upskilling decisions. Integrations with ATS, LMS, and HCM systems ensure this intelligence flows through the hiring and development processes seamlessly. At the same time, we embed bias checks and change management to ensure fair and smooth adoption. The result is actionable skills intelligence. HR leaders get clear metrics like time to fill, internal mobility rate to show value, while employees get transparent career paths backed by evidence. This holistic approach transforms workforce planning from guesswork into a strategic, data-driven system. All links to sources are available in the text version of this article. You can find the full article at marketgapideas.com/blog. Thanks for listening. This episode was produced using autopod.co, the platform that turns deep research into podcasts, articles, and SEO content automatically. If you want to create content like this for your brand or business, visit autopod.co and see what automated content marketing can do for you.